Welcome to Biogas 2023. My name's Robert Laird. I'm the Director of Carbon Offset Zone. I'm going to share with you some of my experience in biofuels, in particular syngas, or town gas as it was called, when stored in these structures, which you can see in many cities today. These provided fuel for street lighting before electricity. The same fuel also powered 1 million vehicles during World War II, when petrol was scarce. The technology still works today, using pyrolysis to drive smoke from the wood and use it as a fuel. Pyrolysis is the heating of wood without oxygen and converting it into charcoal. The byproducts are syngas and bio-oil, both of which are fuels, and wood vinegar, an organic biostimulant. Which leaves us with biochar, the main product that we're trying to produce. This is a soil amendment which has amazing properties in the soil and animal husbandry. Carbon Offset Zone have designed machinery which can be portable, taken to the site of the woody biomass and converted into these products, as well as utilising the syngas. The syngas drives most of the process, as it's such a great fuel and it burns similar to LPG. It needs to be utilised, otherwise you're just releasing it back into the atmosphere. So we need heat to make the charcoal, so this is how we do it. The process also creates more syngas than it needs to do its job, so that can be used for elsewhere, for cooking or any other purpose you need syngas for. That could be a fuel. It can be harnessed and used later. This is an experiment I did, compressing it into a bottle. Certainly could be useful for other purposes at a later date, or to start the process in the first place. But this is the syngas as it's being released into one of our units, and how it looks as it burns. It's a very efficient, very hot flame, and it burns nice and clean and slow, which makes it ideal for running an internal combustion engine like this demonstration I did some time ago, using clean, cool syngas. This same energy can be used in little camping stoves called gasifier stoves or twig stoves, which use just a small amount of twigs to cook a reasonable amount on. We utilise the bio-oil to fire up the next run. So we take some of the bio-oil that's collected from the previous run and we use it as an accelerant to start the process for the next day to get the fire going. Once the moisture has been driven off, the syngas will take over and it'll run by itself. So the whole process uses no fossil fuels at all. Yet it releases 3 times as much energy as it needs to do the job of turning waste wood into biochar, which is amazing if you need a lot of energy to heat up a large body of water, for example. It's very efficiently designed. You can see the hot gases being burned and reburned. Some's going up, some's coming down. So we've had a lot of attention worldwide. Here I am showing the liquid collection area of my unit. This is another unit that's produced, and the liquids recovery is the container at the back, where the bio-oil can be collected as well as the wood vinegar, both of which are byproducts from the process of making biochar using pyrolysis in our systems. Biochar has been proven to be beneficial, and now this benefit can be extended to wherever you are in the world using our technologies. In summary, I'd just like to say that there is a big future for renewable fuels, biogas, syngas, wood vinegar into our future. Thank you for listening.